Hello children, this video we will solve this quadrilateral revision paper. The first question, it says two consecutive angles of a parallelogram are in the ratio 1:3. Then the smaller angle is. So now to solve this, we have to recollect the properties of a parallelogram. We know consecutive angles of a parallelogram make 180. They are actually supplementary. So whenever there is a ratio question asked, first we have to assume an x with the ratio. So the two angles are 1x comma 3x. Then we know supplementary. The two angles, they add up to 180. What is the property? Adjacent angles in a parallelogram is supplementary. So therefore 1x plus 3x is 4x, which equals 180. So x is equal to 180 over 4. Then it gives me 4 4s are 16, 45 degree. So if x is 45, 1x will be equal to 1 into 45, that will be 45 degree, and 3x is equal to 3 into 45. 5 3s are 15, 135. So they are asking for the smaller angle. So the answer is 45. 45 is the smaller angle. The diagonals of a parallelogram ABCD intersect at O and find the angle OAB. So for the second question, let us draw the parallelogram first and name it. Say ABCD name is given in the question, and they say the diagonals. So the two diagonals AC and BD, they say it is intersects at a point O. And they say angle BOC is 90. So BOC is here. This angle is 90. And BDC is 50. So BDC is this angle. BDC. So it is 50 degree. And we have to find angle OAB. So OAB is this angle. We have to find the angle OAB. I have given a question mark there. So now how to solve this? We know the diagonals intersect at a point O. And also they have given ABCD is a parallelogram. So one way of solving this is, now we know this angle, we can find this angle. Angle DOC. So angle DOC plus angle COB is equal to 180 degree because linear pair. Therefore DOC will be equal to 180 minus 90, that would be 90 degree. So angle DOC is equal to 90 degree. We found this angle DOC as 90 degree. Then look at in triangle DOC. We know angle CDO, we know angle DOC. So this 50 degree plus 90 degree plus angle OCD gives us the 180 degree. This is the angle sum. So now OCD will be given by, if we move these two to the other side, it becomes 180 minus 140, that would be is equal to 40 degree. So angle OCD is equal to 40 degree. So this angle we have as 40 degree. So we have find angle OCD. So we need to find angle OAB. So now we know that in a parallelogram, opposite sides are equal and parallel. So if this is the case, we are going to pull out the transversal property. So here we will say AD side AD is parallel to BC and AC is the transversal line. Transversal line. So just let us go back to the picture. You see AD and BC are parallel lines such that AC is the transversal line. So if AC is the transversal line, then we know that this angle and this angle are alternate angles. That is, angle DCO and angle OAB are alternate angles. These two are alternate angles. So therefore, we will say, therefore, angle OCD is equal to angle OAB because they are alternate angles, and therefore angle OAB is equal to 40 degree. So the answer is 40 degree. For the first question, answer is 90 degree. So DEF for the midpoints of sides BC, CA and AB of a triangle. So ABC is a triangle such that D, E and F are the midpoints of the respective sides BC, CA and AB. So now we have to show the perimeter of triangle is what is given. Perimeter of triangle ABC is given as 15.6 centimeter. We have to find the perimeter of triangle DEF. We have to find. So now, since they are talking about the midpoint theorem, so I'm going to apply. By midpoint theorem, we know that FE is equal to half of BC. Then we know that DE is equal to half of AB and FD is equal to half of AC. Therefore, BC is equal to 2FE and AB is equal to 2DE and AC is equal to 2FD. I am bringing to the other side. Now the perimeter of triangle ABC is AB. Perimeter is nothing but adding all the sides. BC plus CA is equal to 2 times of the inner triangle, which is FD plus DE plus EF. I am bringing the two a common out. So now we know this perimeter is 15.6. So the perimeter of triangle DEF is equal to 15.6 over 2. That gives me the answer 7.8 centimeter. So the answer is 7.8 centimeter. Next question. The quadrilateral formed by joining the midpoints of the consecutive sides of a rhombus is nothing but a rectangle. Fifth question. In the figure ABCD, AEFG are two parallelograms. If this angle is given as 55 degree, angle C is 55 degree, we have to find angle AEF. We have to find this angle AEF. So we know that when two parallelograms are given, in the parallelogram ABCD, we know in parallelogram opposite angles are equal. So this angle will also be 55 degree. So angle DAB or angle GAE is equal to 55 degree. So now we also know that in parallelogram AEFG, the adjacent sides are supplementary. That is, angle GAE plus angle AEF is equal to 180 degree. Adjacent angles are supplementary in a parallelogram. Angles are 180 degree. So therefore, angle AEF is equal to 180 minus angle GAE. That would be 180 degree minus 55. That gives me angle AEF is equal to 125 degree. So the answer is 125 degree for the fifth question. Next question, sixth question. Two opposite angles of a parallelogram are 3x minus 2 and 63 minus 2x. Find all the angles of the parallelogram. So we know that in a parallelogram, opposite sides are equal. So if this is the parallelogram, the opposite sides, this angle they have given it as 3x minus 2, and this angle, let us consider these two angles are given. So we know that in a parallelogram, opposite angles are equal. So 3x minus 2 will be equal to 63 minus 2x. Why? Opposite angles are equal in a parallelogram. So therefore, when I bring the x to the other side and 2 to the other side, a linear equation. So 3x plus 2x would be equal to 63 plus 2. So 5x would be equal to 65. X is equal to 65 over 5. That would be 13. If x is 13, so the angle, one angle will be 3x minus 2. Then it would be 3 into 13 minus 2 would be 39 minus 2 will be 37 degrees. So one angle's angle, this is angle D is 37 degree. Then 63 minus 2x, both the angles are same. So this angle also will be 37. 63 minus 2x is nothing but angle B, which is equal to angle D, because opposite angles are equal in a parallelogram. That will also be equal to 37. So how to find angle C? We know that in a parallelogram, angle D plus angle C makes 180 degree because adjacent angles are supplementary, are 180 degree. So we know that angle D is 37 degree plus angle C is equal to 180 degree. So angle C is equal to 180 minus 37, that would be equal to 143. So if angle C is 143 degree, therefore angle B, which is opposite to angle D, that is 37 degree, and angle C, which is equal to 143 degree and which is opposite to angle A. So these are the angles of the parallelogram ABCD. Next, solve the seventh question now. In a parallelogram ABCD, the bisector of angle A also bisects the side BC at X. Prove that AD is equal to 2 times of 2AB or 2 times of AB. So now when you see the angle bisector, since angle A is the bisector, these two halves are equal, that is given in the figure. So let us assume this angle is 1 and this angle is 2. Let us assume angle BAX is 1 and the angle BXA is 2. So therefore, we know that as angle A is the bisector, since it is a bisector, we know that this angle 1 will be equal to full angle half of full angle A. Let us keep this as 1. Then we also know that since ABCD is a parallelogram, it's a parallelogram given. So we know that in this ABCD parallelogram, We know sides AD is parallel to BC and AB is the transversal line. Transversal. So if this is the case, we know angle A plus angle B is equal to 180 degree. Adjacent angles in a parallelogram are supplementary. Adjacent angles property. Or we'll say co-interior angles. Since we say it's a transversal line, we can say it is a co-interior angles makes 180. So now we know that from this I can say angle B is equal to 180 degree minus angle A. Now let us take the triangle. In triangle ABX, we know angle 1 plus angle 2 plus angle B is equal to 180 degree. This is angle sum property. Then we know angle 1 is equal to half of angle A plus angle 2, we'll keep it as angle 2 plus B is 180 degree minus angle A is equal to 180. So this 180 gets cancelled. So if we take an LCM, it would be angle A plus 2 angle A minus 2 angle A is equal to 0. 2 angle 2. This is 2 angle 2. So when I solve it, this would be 2 angle 2 minus angle A is equal to 0. Angle 2 is equal to, this angle goes to the other side, angle A by 2. So or I can say half of angle A. Let us keep this as 2. So from 1 and 2, so from 1 and 2, what is 1? 1 we have just proved that angle 1 is equal to half of A. Now we have proven that angle 2 is also equal to half of A. Then from 1 and 2 you can say that angle 1 is equal to angle 2. Then again go back to the triangle ABX. So we have angle 1 is equal to angle 2. If that is the case, then the side AB will be equal to BX. So if we want to put it correctly, BX will be equal to AB because this is angle side opposite to equal angles are equal. Equal angles are equal. Then in a triangle, side opposite to equal angles are equal. So now multiply both the sides by 2. Sides by 2. So I get 2bx is equal to 2ab. So we know that from the diagram 2 times of is x is it's a bisector. It cuts BC at x. So x is nothing but the midpoint. So we know that 2 times of bx is nothing but BC. So BC is equal to 2AB. I can say BC is equal to AD because in a parallelogram opposite sides are equal. So instead of BC I will write AD is equal to 2AB. Therefore AB is equal to 2AB is equal to AD or AD is equal to 2AB. Hence proved. Eighth question. Prove that the bisectors of the two adjacent angles of a parallelogram intersect at right angles. So for that let us draw a parallelogram first. AB, CD. The bisector of the two adjacent angles or two consecutive angles. So let us take the bisector of angle A, bisector of the angle B, let them meet at point P, and let us mark this as angle, half of angle A as 1, half of angle B as 2. Now we have to prove they meet at a point where the angle APB is 90 degree. So how do we start? We know that in parallelogram ABCD, we know AD is parallel to BC and AD is parallel to BC and AB is the transversal. If that is the case, AB is the transversal line, then we know full angle A plus full angle B is equal to 180 degree because co-interior angles make 180. They are co-interior angles. Then I do half both the sides, because finally I have to show half the angle. The small triangle I have to come. So that is the reason I am halving both the sides. So half of angle A plus half of angle B would be equal to 180 over 2. So therefore half of angle A is nothing but angle 1. Half of angle B is nothing but angle 2. So angle 1 plus angle 2 is equal to 90 degree. Let us have this 1. Now in triangle APB, we know that angle 1 plus angle 2 plus angle APB is equal to 180 degree because angle sum property. This is because of angle sum property of a triangle. We already know that from 1 we know that angle 1 plus angle 2 is equal to 90 degree plus angle APB is equal to 180 degree. Therefore angle APB is equal to 180 minus 90 goes to the other side. The sign changes. Therefore it is proved that angle they intersect at right angles, that is given by 90 degree. Let us solve the ninth question. Show that the line segments joining the midpoints of the opposite sides of a quadrilateral bisect each other. So first let us draw a quadrilateral. Let us draw a quadrilateral A, B, C, D. Then they say the line segment joining the midpoints of the opposite sides of the quadrilateral bisect each other. Let us consider these are the line segments. Let us consider PQ, RS are the midpoints of side ABCD. So the logic here would be, they say ABCD is a quadrilateral. So now we will prove that we'll connect this point PQ, QR. We'll prove that PQRS is a parallelogram. So if I prove PQRS is a parallelogram, I can say the diagonals bisect each other. So that way I can say the line segments bisect each other also. So now, we'll explain this. So we'll say we have to explain all this. ABCD is a quadrilateral and point PQ, R and SR. Since the figure is not given, we are drawing the figure and adding the points, writing in words of sides AB, BC, CD, DA. So now here for solving to prove that it is a parallelogram, so I will join the diagonal AC. So here in triangle ABC, PQ are the, since they talk about the midpoint, I use the midpoint theorem. So here according to midpoint theorem, we know that PQ is parallel to AC and PQ is equal to half AC. Then similarly in triangle we have RS. In ADC we have RS is parallel to AC and RS or SR will be half of AC. Then Therefore, from let us have this as 1 and let us have this as from 2. So we know from 1 and 2, we know that PQ is parallel to RS and PQ is equal to RS. Similarly, if you take the diagonal DB, if we connect the diagonal DB, so if we apply the midpoint theorem, similarly, in triangle ADB, we know that SP or PS is parallel to DB. PS is parallel to DB and PS is equal to half of DB. Same way in triangle DBC, we know that QR is parallel to DB and QR is equal to half of DB. So therefore we know that PS is parallel to QR and PS is equal to QR. So when you see this PS equal to RS, PQ is equal to RS and PS is equal to QR, their opposite sides are equal. So since PQ is equal to RS and PS is equal to QR, their opposite sides are equal. So opposite sides are equal. So in a quadrilateral, if opposite sides are equal, we can say that therefore PQRS is a parallelogram. We can say that PQRS is a parallelogram. So we also know that in a parallelogram, diagonals bisect each other. Diagonals bisect each other. If that is the case, then the line segment, what are the line segment connecting the midpoints? PR and SQ will also bisect each other. Therefore, the line segment PR and SQ also bisect each other. Let us solve the 10th question. P is the midpoint of side AB of a parallelogram ABCD. So first let us draw a parallelogram ABCD. ABCD. They say P is the midpoint of side AB. So this point is P. A line through B parallel to PD meets DC at Q and AD produced at R. So now they say, so now a line through B parallel to PD. So the PD is connected and a line through B meets line through B parallel to PD. So I will draw a line parallel to PD and meets DC at Q. So this point is Q, meets DC at Q, produced at R. So this point is R. They are meeting at a point R. Okay. And we have to prove that first one we have to prove AR is equal to 2BC. So what do we say? We know that P is the midpoint. It's given P is the midpoint and we also know that PD is parallel to PR. That is what given in the question. So therefore in triangle ARB, we know that D is the midpoint of AR because this is the converse of midpoint theorem. Because P is the midpoint, then D also will be the midpoint. Converse of midpoint theorem. Midpoint theorem. If that is the case, therefore, if D is the midpoint, we know that AR is equal to 2AD. So I can also, therefore, I can also say AR is equal to 2BC because AD is equal to BC where opposite sides are equal, opposite sides of a parallelogram ABCD. So hence proved. First part is proved. AR is equal to 2BC. Second question we have to solve. Prove that BR is equal to 2BQ. Since in parallelogram ABCD, we know that CD is parallel, CD is equal to AB and CD is parallel to AB. And since CD is parallel to AB, I can say DQ is also parallel to AB. Then I take the triangle RAB. In triangle RAB, we know that in triangle RAB, since D is the midpoint, we know that D is the midpoint of AR and DQ is parallel to AB, since D is the midpoint. So then if D is the midpoint, then Q also will be the midpoint. So also Q is the midpoint. How Q is also the midpoint of AR? This is because of not AR, of RB. Of RB, because converse of midpoint theorem. Midpoint theorem. So then, therefore, I can say, since Q is also the midpoint, I can say BR is equal to 2 times of BQ. BR is equal to 2 times of BQ, hence proved. So let us solve question number 11. So they say AD is the median of triangle ABC. So let us draw a median AD. Okay, and E is the midpoint of AD. E is the midpoint of AD. Fine, I'll mark the E. Then B is produced to meet AC at F. So B is produced to meet AEF. This point is F. So we have to prove AF is equal to 1 by 3 AC. AC over 3. To solve this, we have to do a small construction, because since again here the midpoint is used, we are going to use the midpoint theorem. So we do a small construction. What is the construction? Through D, we are going to draw a line which meets FC at K. Through D, we are going to draw a line K which meets FC at K. So through D, draw a line that meets FC at K. Fine. Now we take the triangle. In triangle ADK, we know that E is the midpoint and EF is parallel to DK. Then if E is the midpoint, we also know that F is the midpoint. So F is also the midpoint. If F is also the midpoint, we know AF is equal to FK. We will keep this as 1. Then let us take in triangle BCF. So I have to form a relation. So I am finding out the relation between AF, FK and KC. So here we know that D is the midpoint of BC, and we know DK is parallel to BF. Since D is the midpoint, then K is also the midpoint of FC. Therefore, FK would be equal to KC. Let us keep this as 2. So from 1 and 2 we know that AF is equal to FK is is equal to KC. If this is the case, therefore AC will be equal to AF plus FK plus KC. So using this equal to, all the three sides are equal. So all the three halves are equal. So AF plus AF plus AF, because we know FK and AC are equal to AF. So AC is equal to 3 AF. I can say, therefore AF will be equal to, I can bring the 3 to the other side, becomes AC over 3 or 1 by 3 AC, hence proved. Let us solve the 12th question. So dimensions of Rangoli ABC is 24 centimeter, 32 centimeter and 28 centimeter. Garland is to be placed along the side of PQR. So PQR is the garland, which is joined by the midpoints of the sides of triangle ABC. So we are going to answer the question. First, find the first question. Find the length of QR. So we know that by midpoint theorem in triangle ABC, QR is equal to half of BC. That would be half into 32. That gives us 16 centimeters. So QR is equal to 16 centimeter. Here we are using the midpoint theorem concept. Second question, what should be the length of the garland? As we know, the triangle PQR is the garland. So perimeter of the triangle PQR gives the garland. Is equal to length of the garland. Length of the garland. So for perimeter, I should note all the three sides. So PQ is equal to half of BA, that is equal to half into 24, that is equal to 12 centimeter. Then QR is equal to half BC, that is equal to half into 32, that would be 16 centimeter. We are using everything, we are using the midpoint theorem concept. Then QR found, then RP is equal to half of AC, that would be half into 28. That would be 14 centimeter. So therefore perimeter, or for perimeter of triangle PQR is equal to 12 plus 16 plus 14, that would be 42 centimeter. So length of garland is equal to 42 centimeter. Then third question, justify PBQR is a parallelogram. There is this PB, this one. PBQR, this is a parallelogram. So we know that PQ is equal to half of AB. We also know that P is the midpoint. So I can say, instead of half of AB, I can say BR. So then we also know that PQ is parallel to AB. Then I can say PQ is parallel to BR also. Keep it as point number 1. Then what about RQ? RQ is equal to half of BC. Instead of half of BC is nothing but BP. I can say BP. Also RQ will be parallel to BC. Then RQ will also be parallel to BP. Let us keep this as 2. So everything we are applying the midpoint theorem. So from 1 and 2, we know that PQ is equal to BR and PQ is parallel to PQ is parallel to BR. Then RQ is equal to BP and RQ will be parallel to BP. So here opposite sides are equal and parallel. So opposite sides are equal and parallel, which is a property of a parallelogram. Therefore, it is proved that BPQR is a parallelogram. Last one, we have to show that triangle PQR is congruent to triangle QPC. So where is the triangle PQR? This is central triangle PQR. QPC is the shaded triangle, which I am shading it now. QPC. So in triangle PQR and QPC, PQ is equal to PQ, which is the common side. Then PR is equal to half of AC, which will be equal to QC. Therefore, PR is equal to QC. So now we have shown that all the three sides are equal. So by triple S congruence, triangle PQR is congruent to triangle QPC, hence proved.